Good afternoon, everyone. We are here for the live session for the ongoing MOOCs course on fundamentals of nuclear power generation. Now, uh, this is the first live session that we are going to have for this particular course, and I am expecting some response from the side of the audience. So we have to wait to see whatever queries we can get from your side, and I shall be available here for quite some time to respond to your queries. Those who are doing this particular course, I guess you are following whatever we are sharing in this particular channel, the videos, the assignments, etc., whatever we are having. And therefore you may have seen how we have progressed till now. Just a second. Okay, so if any queries that may come in, I shall be available, as I have just told, to respond to those queries. In this course, we have seen that it's a 12-week course, and we have already gone almost to 2/3 of this particular course. Therefore, we have already covered content up to week number 8. And if you have followed the content carefully, then must have seen that we have started with discussing some of the fundamentals, starting with the fundamentals of nuclear power, talking about the present status of nuclear energy worldwide and also in our country. Then we started with the fundamentals of radioactivity, talked about the structure of nucleus and different kind of nuclear interactions which lead to the generation of energy, or I should say conversion of mass into energy, which is the primary source of nuclear power. We have talked about different kind of interactions that a molecule can, or I should say nucleus can undergo, and also the reason behind each of those type of reactions. And then in the third week, we have talked about the nuclear fission, which is the most prominent kind of nuclear reaction that we consider for the purpose of our course, during which only a small change in mass can lead to huge amount of power production, and that with suitable technology can be used for external applications. So we have talked about the nuclear fission, we have talked about chain reaction, what do we mean by a sustainable chain, what are the conditions required for sustaining a chain reaction, and also analyzing different kind of nuclear chains that we have done till the over the first 4 weeks of this particular course. Then we went to the discussion of thermal hydraulics. That is, we have talked about the heat transfer and fluid flow to nuclear reactors, where basically we have made use of the fundamental concepts of heat transfer and nothing specific. And once we have got some idea about the thermal hydraulics, then we started talking about different kind of reactors. Of course, we had a module on reactor control, which is one of the toughest module for this particular course, where we talked about the role of delayed neutron in particular in sustaining the reaction chains. And also we have seen how we can make use of the delayed neutron fraction to get delayed neutron fraction to get an idea about whether a chain is sustainable or not, whether we can control the rate of reaction or not. Though the delayed neutron fraction is a very small one in comparison with the prompt neutron, but that plays a very important role in controlling the nuclear reaction rate, which we have explored as a part of this module number 6. And now in these weeks, we are talking about different kind of reactors. We have talked about thermal reactors. As you have seen, there are varieties of thermal reactors. The classical pressurized water reactor and boiling water reactors are there. And also the so-called generation 1 or generation 2 reactors are all of PWR or BWR type, and gradually we went on to the pressurized heavy water reactor. Most of the Indian early generation reactors are pressurized heavy water reactors, so-called CANDU reactors. And there can be also gas cooled reactors, and we can also have fast breeder reactors. In module number 8, we are specifically talking about the breeder reactors, where breeding reaction itself is important. That is, along with the generation of power, some nucleus, or I should say some neutrons, are also used for production of new fuel. Because we have seen whenever we are talking about the fission reaction, every nucleus along with its fission cross section can have also some non-fission capture cross section. That is, non-fission capture cross section is always there for any kind of neutron or any kind of nucleus, but some of the nucleus can also have significantly high fission cross section, and whatever neutron gets absorbed, not necessarily that is a waste, and that's what lead to the breeding reaction. Like whenever uranium 233 or uranium 232, I should say, absorbs a neutron in a non-fission capture reactions, it becomes uranium 233, which through couple of steps of beta decay gets converted to thorium 233, which is a fissile nucleus. And though uranium 232 is a fertile one and it does hardly has any fission cross section, but thorium 233 is a fissile nucleus and we can use that for production of nuclear power. The same is applicable for uranium 238, which itself is a fissile, which itself is a fertile one. That is, it doesn't have any fissile cross section and it directly can't be used as a fuel. However, when it absorbs some neutron, it becomes uranium 239, which through successive stages of beta decay gets converted to a fissile nucleus. And this way, the conversion of a fertile nucleus to a fissile nucleus is called the breeding, and that is the essence of the working of the breeder reactors. And we are talking about this breeder reactors or the working on the breeder reactors in this module number 8. In the remaining part of the course, we have some different types of topics, like we are going to talk about nuclear fusion. Fusion is a different kind of reaction compared to fission, where fission is applicable for heavier nucleus. That is, once a nucleus absorbs neutron, it breaks into two lighter nuclei, and the difference in mass leads to the production of huge amount of energy. In case of what I should say, in case of fusion reaction, we are talking about the other end of the spectrum. That is, we are talking about very light nuclei. Say two different isotopes of hydrogen, the deuterium and tritium, when they get absorbed with each other, that also leads to some kind of mass defect, which can get converted to large amount of energy. I'd like to take you back to the binding energy curve that we have explored at the very early stages of this particular course, where the all nucleus want to have the highest possible binding energy per nucleon, but only those having mass number in the range of 60 can maintain binding energy per nucleon close to the highest limit. Those which are much heavier than that, they goes through the fission reaction so that they gets converted to lighter nucleus and we have energy through the fission reaction. However, when you are talking about the lower end of the spectrum, then the lighter nuclei, they have the option of joining with each other and accordingly getting converted to a heavier one and produce energy via the fusion reaction. That will be explored as a part of the module number 9. And then we shall be talking about the biological effect of radiation a bit. Then some concepts about reactor safety and security, different kind of protocols will be talked about. And finally, we shall be closing up by talking a bit about waste management and economics of nuclear reactors. Now, this course, truly speaking, is an old one. That is, I recorded all these videos quite a few years back, and since then it is running either in repeat or rerun mode. I don't have much option of sorry, I don't have much option of updating these videos. Hopefully, I shall be getting an option of doing that later on. Since that time, I have taken this course quite a few times as a master's level elective at IIT Guwahati itself, where both masters and undergrad, finally undergrad student registered for this course, and I've been able to update that for quite a bit. I'd have loved to add some of those materials in this, which however is not possible, but lots of content about the structure of the nucleus, particularly the fundamental elements of nature, topics like quarks and leptons, the basic forces of the universe. In the universe, there are generally 4 fundamental forces, out of which the so-called strong force and weak force are very important from nuclear reaction point of view, along with the electromagnetic and gravitational force. These are the 4 fundamental forces of nature. And I'd like to talk a bit about those, which I do in my regular classroom, during my regular classroom lectures. However, I don't have that scope here. So we have to restrict ourselves to whatever we have covered as a part of the official syllabus. Now I can't see any question coming to the live chat. I have already checked the Excel sheet that has been that was shared with you. There are no questions, and I don't think there is any unanswered question lying in the course portal as well. Generally, our TAs are quite efficient in handling those, and they are trying to answer almost all the questions. Sometimes answering on their own without even bothering to discuss with me, which is fine because they already know the answer, and so they're trying to answer that the earliest possible. In this live session, I am dependent on your involvement, because if no questions are coming, then I am just talking in front of a blank screen. But I have to wait for some more time, during which probably I can review some of the important things that we have done as a part of this course. Like, and do you remember what do you mean by radioactivity? Radioactivity is a type of nuclear reaction where we are actually talking about the process of transmutation. That is, one nucleus getting converted to another nucleus during some particular procedure, during which there will be some kind of mass defect, mass difference between the reactant and the product, which leads to energy production or energy absorption. Energy absorption is also possible, of course, during nuclear reactions. The transmutation is this process of changing a number of nucleons. Almost all elements that we have in nature can have multiple isotopes, some of which are stable, some of which are unstable, and depending upon their level of instability, they can participate in different kind of nuclear reaction. Okay, I have bought something here. I have got a question about sharing the reference book to get in-depth understanding or detailed derivation of the diffusion equation and or simplified reactor types that was covered in module 5 and 6. Now, in module 5, we have talked about the reactor thermal hydraulics, where we have just done heat transfer analysis. I don't think there is any specialized book required for that. Maybe I would suggest you can go through the book of Power Plant Engineering by Professor P.K. Nag, where there is a chapter on nuclear power generation. I have not taken a look at the newer version of this particular book. If they have not changed, then there was a section. I was talking about the second edition. So they have a chapter on nuclear power generation, and there was a section about this thermal hydraulics thing, where they have talked about the heat transfer problem in both Cartesian and cylindrical coordinates. And I think that should be sufficient for whatever we have discussed as a part of the module 5. Module 6 is slightly different. Now, I have to see what I can do in this. Okay, I will try to share the name of some of the reference book as a part of the course module. Just give me 2-3 days. I shall be sharing you the name of 2-3 books. In fact, whatever official syllabus we have, I think the names of the books are already there. But still, if any thing I have missed there, then we can check that out. I'm trying to go through the official syllabus that is there as a part of the course portal, but sorry. So fine, there is no point exploring. I'll try to share the names of 1 or 2 books, which if you can access, you can go through to get some more details about the module 6, where we have talked about the reactor control, where we have talked about the process of neutron diffusion. Accordingly, we have developed the fundamental equations of diffusion, and then we have seen how the delayed neutron fraction can help us in controlling the rate of reaction. I hope that will suffice. Just give me 2-3 days. I'll definitely try to do it in the official portal. Just keep checking that out. Okay. As talking about some of the earlier concepts like radioactive reaction, like we can have something like the alpha decay. Alpha decay generally is associated with heavier nucleus, something which is having too many neutrons compared to the number of protons. They can shed a helium particle or an alpha particle, so that there is change in both number of protons and neutrons in the final nucleus. We can also have beta plus or beta minus decay, or so-called electron decay and positron decay. We know during beta decay, neutron shed or nucleus shed one electron, because of which there is an increase in the number of proton and reduction in the number of neutron. Beta decay probably is the most common kind of nuclear reaction we can identify with unstable nuclei. The opposite one is beta plus decay, where a neutron can get converted to a proton and electron, or I should say, uh, sorry, uh, the uh, beta plus decay or positron decay is where a proton gets converted to neutron and a positron, and therefore there is an increase in the number of protons, and we have that positron coming out of this. However, that positron can combine with the orbital electron, and therefore there is the annihilation of mass leading to the production of energy. We can also have the very common gamma ray release. The excess energy available often can come out of the gamma rays, and also we can have some less common kind of nuclear reactions as well. And once that is done, we have talked about the nuclear fission reaction. Though almost all the nucleus that we can have in our nature have the capability of absorbing neutron in a non-fission capture reaction, only very few nuclei can have fission cross section of any significance, and therefore and that also depends upon the kinetic energy level of the neutron itself. So once a neutron with fission cross section having sufficient kinetic energy collides with the neutron of sufficient kinetic energy or appropriate kinetic energy, we can have fission reaction where the heavy one gets broken into two lighter ones, and we have the production of energy. We have seen that uh, a single uranium-235 nucleus can participate in fission reaction and producing about 200 MeV of energy, which is really a significant amount of energy. And also in the very first module, we have compared for a given amount of mass, the amount of energy released by during nuclear reaction is about 10 to the power 5, 10 to the 6 to 10 to the 7 times in comparison with an equivalent chemical reaction. Because here we are talking about conversion of mass is more significant in nuclear reaction in comparison with chemical reactions. And that's why even very small amount of difference in mass can lead to the production of huge amount of energy. In the chain reaction, we have seen how it's just not single reaction, rather both the products of nuclear fission, both are generally unstable in nature, and therefore they go through a series of beta decay and other kind of successive decays, leading to the formation of chain till both of them reach some kind of final stable nuclei, and that's what we call the chain reaction. And also during every fission, once one neutron gets consumed, 2 3 more gets produced, each of which generally have the capability of participating in further fission. But in order to sustain a chain, we can't allow all of them to participate in fission, and for every fission in one generation, we want exactly one fission in the next generation in order to have a stable chain. We don't want the reaction to die down, but at the same time we don't want it to explode as well. So that's something that have been covered as a part of that chain reaction. If you have already got these concepts, if not, you can always write back to me. I am not able to find any question in the portal. If there are no further questions in this, then I may have to stop this live session. However, me and my TAs are always available or always accessible through the course portal. So you can keep asking the questions, and we shall be happy to respond to you there. Now, as there are no more questions coming, I'd request my office to close down this particular live session, because I can't see any more participant in this, and also questions are also not coming here. So can we please stop this live session then? Yeah. So we are closing this live session here. Thank you, everyone. I'd request you to send your questions to the course portal. Thank you.